Alright, so what we want to talk about here are the different sampling methods. So if we wanted to collect some data, what are ways that we can actually collect the data? So what we're going to focus on is if we wanted to gather information about PCC students and how much they pay per month on housing. Say we wanted to get the idea of average payment per month. What we're going to talk about are these different methods of getting that information. So the first one is to gather a census, which means to sample the entire population. So this completely links to like the US Census, where they gather information from absolutely everyone that's an American citizen in terms of how many people are in the household, average income, things like that. So for us, this is where if we're just focusing on PCC students, this would mean we survey every PCC student. So we survey everyone that's part of our group. And so for us, I mean, what gets difficult about that is it's very difficult to obtain, because while we send out the surveys to every PCC student, what we need to do is guarantee that we get every PCC student's results. And that can be very difficult, especially if you're just using email or calling. It's easy to leave some out, but if it's a census, we should be getting all of those results. So the pros of a census is that when we get this information, it's very accurate. We have everything we need. But some cons would be that it's very difficult to obtain. Getting population data is so difficult to obtain, and with that, like if we were hired by the school to collect this information, this would take us a long time to accomplish. So this takes a lot of time, and then if they were paying us, anything that takes a lot of time also takes a lot of money and resources. So a census is great for getting that exact data, but very, very difficult to accomplish. We could do instead is a simple random sample, or for short we can say SRS. A simple random sample is where sampled individuals are randomly chosen. And when they're randomly chosen, they should all have an equally likely chance of being selected. So they're randomly chosen. So something about randomness that we need to think about is that we as human beings are not so good at being random. So what we often do is use a computer to randomly select items for us. So what we could do is use a computer to randomly select, and let's say we need to choose a sample size. Let's say we randomly select 100 PCC students. And we'll gather the information from just them. So it's up to the researcher, the sample size, and that's really the only kind of downfall of a simple random sample. So the only thing you need to be careful of is that you have a large enough sample size. You don't want your sample size to be too small, because then it won't give you an accurate representation of the population. You don't want it to be too big either, because then you're getting into census territory, and then those cons start occurring. So you kind of want to do the Goldilocks method of not too small, not too big, somewhere in the middle is just right. But simple random sample, this is a fantastic way to run a survey, to collect data. If you can have a simple random sample, that's the way to go. The next two, stratified and cluster, I kind of want to talk about at the same time, just because they sound very similar and they're commonly mixed up with each other. Both of them work with the idea of taking our population and breaking it into subgroups. So for both of these, we're going to break the population into subgroups. So we take our population, put into subgroups. Same thing with cluster. So we break the population into subgroups, and we'll talk about ways to do that. So, once we do that, then how we treat the groups is what differs between these two sampling methods. So stratified, we take our population and then we separate it into different subgroups. What we do is then we look at each group and we take a random sample from each group. So, and take a random sample from each group. So what this would look like is once I break the population into groups, I would choose some number and we would just talk to a few people or things within each of the groups that we have. So it's a great way to make sure you get into each of these groupings. It can be beneficial for our data to make sure we have this kind of widespread data that's collected and that we take a random sample from each. With cluster, what we do is we break the population into subgroups and randomly select groups to survey. So with this one, what we do is we take our population, we break it into our subgroups, and then we randomly select some groups. So let's say a computer told us to talk to that group, that group, that group, and that group. Then what we do is once we've chosen certain groups to talk to, we survey everyone in each of those groups. So we talk to everyone in this group, everyone in this group, everyone in that group, and absolutely everyone in that group. So the thing about cluster is that you're going to leave out entire groups. And that's where when you make the groupings with cluster, you kind of want to be careful with how you choose groups. It should be okay that you're leaving out groups there. So let's look at if we applied this to collecting data from the PCC students. So let's say we want to think about a way that, yes, we want to talk to all of the groups in a way that's beneficial for portraying an accurate kind of view of housing per month. So something I might think of is that I want to make sure that I kind of talk to people that live in all of the neighborhoods, so my data doesn't get influenced by like only rich neighborhoods or only poor neighborhoods. So what we can do is separate students by neighborhood. And then from there, after we separate students from neighborhood, then survey, let's say 30 students, 30 random students. Let's say they then survey 30 students randomly from each neighborhood. This will be stratified, since we use those groupings and we talk to all of the groups, but just a certain number of people from each group. So something we want to think about with this one is that while it's great for getting to each of the groups, kind of a con to it is that the groupings need to make sense. So do the groups make sense? That's something we want to think about, because if the groups don't make sense, then what's the point of doing it? We want to make sure that they make sense so that we are collecting the data in a way that's beneficial to us. With cluster, what we would be doing is, and with cluster, it's almost like we don't want the groups to make sense. Like, I wouldn't want to use neighborhoods here because we would be leaving out entire neighborhoods. So that wouldn't be very beneficial. So with this, when you think about breaking into groups with cluster, you want to break them in a way that's just kind of easier for collecting data. So maybe instead of separating by neighborhood, maybe I separate students by first letter of their last name. Students by the first letter of their last name. And then from there, I just choose randomly some letters. say we randomly choose 5 letters, and then we would survey everyone with those letters. So if we only chose 5 letters, like say we had a computer randomly choose 5 letters, so say it was B, F, I don't know, M, P, T. The idea would be that we'd talk to all students whose last name starts with B, talk to all students whose last name starts with F, only students with those first letters in their last name, but we would talk to everyone in those groups. So downfall of this one, some cons, would be that entire groups are left out. So with that, just want to be setting up the groups in a way that that doesn't influence the data itself too much. Like housing per month isn't going to be related or at least shouldn't be related at all to the first letter of your last name. The last 2 we want to talk about, so systematic. Systematic is where we select every nth individual. And n is just a number that the researchers choose. So it could be you survey every 5th individual, every 100th individual. Just choose a number and it kind of sets this kind of separator for the data. So like for us, say we make a list of PCC students, and we survey every 15th student. So when we do this, it should be fairly random. There might be a lack of randomness, but should be pretty random if we're just selecting from a list and using this kind of numerical separator. We need to be able to count our population. We need to be able to make a list like this in order to use this method. And something you want to do, and this is a possible con, is that you want to make sure you end up with a large enough sample size. Like using 15, that's going to be good, because there are a lot of PCC students. If we select every 15th PCC student from the list of all students, we're going to have a decent sample size at the end. If I had done like survey every 1,000th student, then we might end up with a pretty small sample size. So you want to make sure you choose a number there that if you use that increment, it's going to give you a large enough sample size in the end. And then our last one is multi-stage, which is where you mix 2 or more of these methods up here. So use multiple sampling methods together. And in terms of what can be the cons of this one, really it's just what's inherited from the ones that you're using. So they're just kind of inherited based on which methods you choose. So let's say for PCC we decide to first use cluster. So say we randomly select 5 last name letters, or last name first letters, let's say. And then say from there, so we have these 5 groups, so we have this list of students whose last name begin with those letters. Say that ends up being a huge list and is going to be too difficult to survey all of them. What we could then do is, using that list, create a random sample. So then we could go on and use simple random sampling and randomly select 100 students. So with that, in terms of the cons, we'd inherit that we are leaving out entire groups by leaving out certain last name letters. Also, we want to make sure we end up with a large enough sample size. But with these layers, it can make it more obtainable in case like clustering just left us with almost running a census in terms of sample size. We can shrink it down by then running a simple random sample. So those are our sampling methods.